Hello, everyone. Welcome to Swiflearn live classes. So, how are you? Hope everybody's fine, enjoying themselves, safe in their, especially in their houses, right? Yeah. So, welcome to the Swiflearn company. We are the online teaching platform, and we teach students, lovely students just like you. We teach you all. So today, what's the topic? Who am I? And everything. Just relax, be ready, and I'll introduce you the things. Okay, slow and steady. All right. So my name is Harneet, and I am the Swiflearn maths teacher. So I welcome you all to Swiflearn class, and today I'm going to teach you mathematics. Which topic? Maths is so vast, ma'am. Which topic? Just relax. I'll introduce you. So let's start. Yes. So the topic for today is ratio and proportions. What is ratio and proportions? Any idea? Does anyone know what is ratio and proportions? No? Yeah. Yes, I can see a couple of people saying that they know what is ratio and proportions, and some would be like, no, ma'am, we don't know. Not a problem. After this class, I'm pretty sure that you'll all know what is the topic and what is all about it in mathematics, right? So we'll go slow and study, and we'll explain you each and everything so that the thing is not a problem for you anymore. You are through with this topic completely. Yeah, so good to go. Everyone excited? Yes, even I am also very excited to teach you all. Yes. So let's start. Let's begin. Or just wait. Okay, just wait for a few more minutes for everybody to join in. Yes. Can I see? Yes. Okay. Yeah, now I can see a lot of people have joined in. So let's begin the topic, ratio and proportions. Okay, so before starting this, I need to tell you what are the topics we will be considering in this class. In this session of 1 hour, we will be covering topics as comparing same quantities, meaning of ratios, and equivalent ratios. So these are the three categories or three subtopics of the chapter ratio and proportions that we are covering in this 1 hour class. So let's begin. Good to go? All right, let's start. All right, before starting and telling you what is ratio and what is proportions, so just give me a situation, okay? Suppose there is one big jar and it has 30 cookies, yummy, yummy cookies. 30, that also, how many? Can you see? 30 cookies, so many. Okay, so I'm very excited to see and to eat them, but I'm not there, right? There are three boys there. The first boy's name is Rahul, the second name is Rohit, and the third's name is Raj. So they are the three friends or three brothers who are there together and want to eat those cookies. So what's happening? Everyone will go and grab their most cookies, but hopefully everyone gets equal. But in this case, it is not the condition. What happens? Oh, Rahul ate just 5 cookies. Okay. Whereas we see that the Rohit ate or eat 10 cookies. Okay. He ate more. Raj, he ate or eat 15 cookies. He ate the maximum number of cookies. Oh my God, Raj, you ate so many sweets. Okay, so coming back to the topic and the question, it says, how many more cookies Raj eat as compared to Rahul and Rohit? So, how many more cookies? How many more? Any idea? Yeah, I know that Rahul ate 5 cookies. Okay, so he ate 5. Rohit ate 10. So he ate 10 cookies. And Raj ate or eat 15. So he ate 15. Right? This is what? Okay. So now the question is asking how many more cookies? How many more? Who ate more? Raj ate more, right? Oh, sorry, Rahul or Raj? Who? Yes, Raju. Raju ate more, right? So Raju ate compared to Rahul. So we'll first compare Raju, number of cookies which Raju has eaten as compared to Rahul. So Raju has eaten 15 cookies, okay? And Rahul has eaten 10 cookies. So I'll subtract. So 15 minus 10, I get 5 cookies. 5 more cookies. Okay. Now, the same question is asking us to compare the other two boys, which are same, Raju and Rohit. So now we are comparing Raju and Rohit. Yeah. Okay. So Raju had, we know that remains the same, 15 cookies. Whereas now the Rohit has eaten how many? 10 cookies. So we'll subtract 10. So we come out to be 5 cookies. So we know how many more cookies have these all guys eaten. We have compared that. Okay, but now there will be a question in all of your mind that, ma'am, you said we are doing ratios, but here you are doing subtraction. Yes, I am saying we are doing subtraction. We are not doing ratio in this particular question. But why? Why are we doing this? The topic is ratio. The thing is that here the question is asking how many more. So I have to see that how many more cookies are we eating, right? But in ratio, this is not the comparison. The comparison is in some other form. Here we are comparing the children who have eaten cookies, that who has eaten more. But whereas in ratio, so in ratio, what do we do? What is ratio? Ratio is comparing. It's the same thing, comparing two units, something we need to compare, same quantities. It's the same thing. But here we compare in how many times. It's the earlier questions in subtraction we used to do how much more or how many more. But here, what we are doing how much, how many times are we, has the person has more. So we are comparing in terms of times. Is it little clear? Is it little clear? No? Okay, just wait, not a problem. I'll give you one more situation and this will clear all your doubts about what is ratio. So let's understand this example. So here it is two girls, right? One is a taller one is a shorter one. That the picture is showing us clearly, right? Okay, so there is Himani and one is Pari. So it says that Himani has 175 centimeters of height. She's tall. The height is 175 centimeters, whereas the Pari's height is 125 centimeters. Okay, so we know the height. I know she's taller, but now if I'm comparing, it's easy. I can subtract. I know how much taller the Himani is, right? This too is done in subtraction. This is already covered there. But now the question says, how many times? Can you see this? It says, how many times is Himani's height to Pari's height? So the question is not asking how much more. The question is not saying to give us a unit or a number by subtracting. Whereas here, the question is saying and asking us to give me the answer for the question, how many times? Okay, so for this is the concept of ratio that comes. So how do we do that? See, Himani is, we have to compare the height of Himani. So first is Himani, right? So Himani's height is 175 centimeters, whereas the height of Pari's height is 125 centimeters. What have I done? I've written one below the other. Yes, I have written one below the other. So I'm writing the number or the unit of Himani on the top and the unit of Pari at the bottom. So what am I doing? I am comparing both the heights in terms of times. How do we do that? So for that, the person whom I want the height first would be written on the top. And to whom I am comparing will, that is in this case is Pari, will be written at the bottom. I hope I'm sounding clear. I'll repeat myself. What am I doing right now? See, there are two people, two girls right now. One is Himani and one is Puri, right? So Himani's height, the question says compare the Himani's height. The first is Himani and the second is Pari. So you have to compare Himani's height with Pari. So we'll write the Himani's height on the top, whereas the Pari's height at the bottom. So now we know when there is in a form of a fractions, like something of division sort, right? So now how will we solve this? It's pretty easy. That we have already covered in our previous sessions, right? So 125, I have to divide by this. So I know these two of the numbers come in 5 table, right? So let me divide both of them by 5. Let us bring it to the simplest form so that we know and the smallest number from which we can compare. See, right now the numbers are very big. So comparison is little difficult for us, right? So solve that, and to bring it to the lower level, we have to bring it to the lowest form possible. So first we'll divide by 5. So when I divide by 5, what do I get? When I divide this 175 by 5, I get 35, right? Similarly, when I divide 125 by 5, I get, how much do I get? 25. Am I right? Hope I'm right, right? Okay, now is it on the simplest form? Is it still on the simplest form? No, it is not. So let's me help you this to solve it a little further. So till now we are at 35 over 25. Okay, so let's see what happens. Now, when there is 35 over 25, we were here. Can you see that? I'm writing it again for you. Now, still they both come in table of 5. We know that 35 comes in the table of 5, same with the 25. So let me divide both the numerator and the denominator. I mean, the number on the top and on the number at the bottom. Let us divide it by 5. So when I divide that, I get 7 by 5. See, that is what is given already in the slide. So what have we done? In this slide, it is written as a direct answer. But how did I reach to that answer? I've explained you. What have we done? We have first divided 175 over 125, both the things by 5, right? When I've done this, I came to 35 over 25. Now I've again divided that by 5 so that I reach to a little more smaller number. Now it is 7 by 5. Now, is 7 by 5 the smallest form? How will I know? It is very easy, right? So we look at a table in which there is 7 as well number is there and 5 is also there. Is there any table except 1? No, right? So that is the lowest form. So I know now the lowest form is 7 by 5. So, but what do I do with 7 by 5? What is this? This comparison in times is known as ratio. So let's come back to the topic and to the more simplest form so that now you know what is actually the ratio, right? Yes. So what is a ratio? When we compare two quantities in terms how many times, then the comparison is known as ratio. How many times? Then the comparison, comparing the things in terms of how many times is known as ratio. Now the question comes, why do we compare? Why do we compare? See, it's normal. It's really very normal in our life. When we see in our house also, sometimes it happens that our mother brings 5 cookies or 5 chocolates, let's say, okay? And there is one elder brother with us. So what happens? He goes and grabs all the 3 chocolates and eats it. Now, being a smaller child, you are just left with 2. It happens? Really? Does happen with you also? Yes, it used to happen with me also. So what we used to do? I used to tell my mother that, see, my brother has eaten more. And now I have left with just 2 chocolates to eat. So this is what we are doing. We are comparing who is having more and who is having less. And that comparison is not done in terms of numbers. It's done in terms of how many times more have you eaten. So this is what is called as ratio. Hope I'm clear now. Yeah? Okay. So now we denote ratio using this sign that are two dots. We call it semicolon. Okay. So how do we do it? See, the Himani's height was 7/5 times the height of Pari. So we write 7 first, Himani, 7/5 was it? So we'll write in a form of ratio. And that is written as 7:5. So 7:2. We say the ratio sign as is 2. IS is different and T2. So is 2:5, or we can say 7:5. So whichever you're comfortable, you can use both the things. It's nothing wrong in that. We are just calling it, right? So generally when I'll be teaching, I am more used to is 2 word. So I'll using that more. So 7:5 is the ratio between the heights, the comparison between the heights. Is it sounding clear? Any doubt? No? Sure? Okay, so if you have, I'm pretty sure at the end of the session, there will be no doubt about what is ratio. We'll keep on proceeding and I'll keep on repeating the same thing again and again so that you have no doubt at all and you can solve the questions on your own. So let's move ahead. Yeah? Okay, let's begin. See, it's already there in the slide, but we have done it, right? We did 7/5, and I've told you already that the ratio is written in form of is 2. So we write the first number first, right? The number on the top first. So 7:5. Clear, everyone? Okay. So let me give you some other situation, something else. What is it? See, there is a yoga class going on in a school. So there are 40 boys and 30 girls in a yoga school. So what is the ratio of boys to girls? What is the ratio of boys is to girls? So now question is itself asking how much, what is the ratio? So that means, what does ratio means? Yeah. What does ratio mean? That's right. Yes, the ratio means how many times. So how many times more number of boys are there as compared to number of girls? Am I sounding clear to you all? All right. So there are 40 boys and 30 girls in the school. So how do we begin? It says that the ratio of boys, so we are comparing the ratio of boys. So boys is on the first, right? That is what the question was saying, comparing the number of boys as to comparing it with the number of girls. Boys are first. So we'll write the number of boys on the top and comparing it to number of girls at the bottom, right? So I'll write number of boys were 40 and number of girls were 30. So I'll write 40 over 30. I have written it is equal to 4/3. Why? How is it equal? Any idea? Yes. Anybody? You can write in the comments. Yeah, I can go through that. Come on. Yes, I can see. Okay. So 40/30. So I know the property of 10. So 40 means 4 multiplied by 10, whereas 30 means 3 multiplied by 10. I know when the same number is there in the numerator and in the denominator, we can cancel it. Or we can directly cancel 0 and 0. That is a shortcut, right? Okay, so coming back, it becomes 4/3. Now, the question did not say give me a number in a form of a fraction, did it? No, it asked for a ratio. So we know that ratio is represented in a form of a number, then a semicolon, then another number. This is the standard form. How do we write a ratio, right? So we know the first number comes first. So 4 is on the top, will come first. He'll come running. I'm on the top. I am the boss, right? I'll come first. So the 4 will come first. It's to the sign of the ratio 3. which is at the bottom, will come later following. Okay, sir, I'll follow you. So by this, we get the ratio as 4:3. So we also say that for every 4 boys, there are 3 girls. So this ratio also compares the things in a form that we want. We are comparing boys and girls, but how do we say 4:3? What does it sound? It sounds that for every 4 boys, there are 3 girls. Hope I'm clear. Yeah. Okay. Now I'll give you a question. Let's see. Can you solve this question or not? Let's see. Okay. So the question is the other way around. It says, now let us find out the ratio of numbers of boys with the total students. Now it's a little different. We are comparing the number of boys with the total students. But the total students are not given. We were given the number of boys are there. It was given that the number of boys were 40. The number of girls were 30. But the question is saying compare the number of boys with the total number of students. But we don't know what is the total number of students. That was not given. So can we solve? Still can we solve it? Think about it once more. Can we still solve it? Yes, we can. See, in a whole class, there will be boys or there will be girls, right? So I know the number of boys, I know the number of girls, so why not add them? Simply adding the number of boys with the number of girls, I'll get the total number of students. Simple as that. So by adding 40 plus 30, what do I get? 40 plus 30 is 70. So now I know number of boys. I know the total number of students. So now can I write the ratio? Yes, pretty much. It's very easy now. So how will I write this? I know that the ratio of boys comes first, whereas the ratio of students will come beneath it, will follow it. So the ratio is number of boys over the total number of students. Yeah, clear? Okay. So number of boys were 40. Total number were, we calculated, right? We added the number of girls and the number of boys together, and that became as 70. So now 40 over 70. Now we have know this. We can solve it into a more simplest form by just striking out the zeros, by cancelling the zeros, right? So that comes out to be 4 by 7. 4 over 7. Okay. Now, but we need in the form of ratio. So who comes first? The top one, the boss comes first, and the later everyone follows them. So similarly, the 4 will come first and 7 will follow it. So 4:7. So the ratio of number of boys compared to the total numbers, compared to the total number of students is 4:7. Clear, everyone? Sure? Okay. Now the next part, you will do it for sure. And I know you'll give me the answers. I'll waiting for your replies and comments. So the question is, try this yourself, okay? It says, can you find the ratio of number of girls to the total number of students in the yoga school? So I'm repeating the question again. It says, find the ratio of number of girls to the total number of students in the yoga school. So I don't know you remember it or not. I'll give the numbers here. So the girls were, what were the girls' number? Girls were, do you all remember what were girls? The girls were 30. Yeah. And the total students were 70. Now tell me what's the ratio. Solve it. Take your time, do it properly, and give me the answers in the comment. I'm waiting for your answers. Let's see who have understood what I have taught you today. Yes. Yes. Okay, just few more seconds so that I can see more answers. Yeah, that's right now. So it says the number of girls. So with girls will come on the top. That is what we have to compare the first unit. So the number of girls are 30 and they are compared with the number of students that are 70. I know I can write the zeros and make it to the simplest form. That is 3 by 7. Is that the answer? Is this the answer? 3 by 7? Sure. No. Yes, you're right. It is not the answer. Ma'am did not give the right answer. We have still not written it in a form of ratio. We have solved it. We are close to it, right? So how do we write ratio? A number is to semicolon the another number, right? So it's 3 is to 7. So the ratio is 3 is to 7. What does 3 is to 7 mean? How do we say it? What is exactly the meaning? Yes, think over it. Take your time. There's no hurry to go about it. We have plenty of time. We can go slow also. Yes, 3 is to 7. That's right. 3 is to 7 means that there are 3 girls to compare to the number of students that are 70. So there are 3 is to 7. 30 girls, sorry, I'm repeating again. 30 girls, total of 70 students. So 3 is to 7 means for every 3 girls, there are from the total of 7 students. So out of 7, there will be 3 girls. So we have solved it from 70 to compare it to 7 now. Can you see the difference? Earlier, the question said 70, but we have bring it down to number of students or as a group of 7. So for every group of 7 students with the equal number which is required, there will be 3 girls in that group. Okay, clear? Yeah. Okay, let's move to another question. Okay. The other question says, now you have to solve this also. Try it. Otherwise, I'm there to help you, right? Yes. So in a college, out of 4,320 students, 2,300 are girls. Okay. Find the ratio of number of boys to the number of girls. Wait. What's the question saying? Okay, I'll repeat the question again. So in a college, out of 4,320 students. So what are 4,320 students? They are the total students. Is it clear, everybody? Yeah. So it's saying out of means these are the total number of students. Okay. So I know the total number of students. Now the next line says there are 2,300 are girls out of these. So I know the number of girls that are 2,300. Okay. Now it says find the ratio of number of boys to the number of girls. Do I know the number of boys? Do I really know? Is the question saying anything about number of boys? No. So how will I solve this? I don't know the number of boys. Do I? No, I do not. So how will I solve it? Yes, I can still solve it. It is very, very easy. How? See, I know the total number of students in the college. When I know the total, I know the number of girls. Can I calculate the number of boys? Can I? Yes, we can. So now try to solve it. I'm giving you at least, okay, 3-4 seconds. Just let me know which are the number of boys. How many number of boys are there in the college? Take your time and solve it. Yes, do it, do it. I know you can do it. Buck up. You know it. You know how to solve this. Okay, will show you the question again if you have any doubt. With the numbers, be careful with the numbers, what you are writing. What operation are you using? Are you using addition, subtraction, multiplication, division? What operation are you using to find out the number of boys? Yes, I know you have done it. You can. It's easy. So how did you calculate the number of boys? Yes, we did it by subtracting, because I know the total and I know the number of girls. So when I know the total, I know a part and I have to calculate the other part. We use the method of subtraction, right? Okay, so let me help you out. Let me solve it on the screen for you so that now you have no doubt. So the total number were 4,320 students. Yeah, is it right? Okay. So out of these, there were, how many number of girls were there? There were 2,300. This was total. These are the number of girls. Oh, sorry. Just a moment. Yeah. All right. So now to calculate the number of boys, what operation will I use? What mathematical operation will I use? I will use subtraction. So when I subtract, I say, okay, 0 minus 0 is 0, 2 minus 0 is 2, 3 minus 3 is 0, 4 minus 2 is 2. This is easy. So what are this? What have I got? I have got the number of boys in the college. I got that? Okay. Now we have to find the ratio. We had to know the comparison of number of boys to the number of girls. Not with the total, with the number of girls. So the number of boys is written first. So we'll write the boy on the top. That's right. So I'll write 20, that is on the top. 2020 on the top. And I'm comparing it to number of girls, and that is 2,300. Can you see this here? Yeah. Yes. So I'm comparing now. This are the number of girls. These are the number of boys. So boys on the top, girls at the bottom, because the comparison is from boys to girls. So boys are written on the top. So how do I solve it? Is it in the simplest form? Can I say this is a ratio? No, it's a big number. I really don't know. How will I know it? It's a very big number. So let me bring it to the lowest form. How do I do it? Okay, I know. Let me cross this. So I'll let that comes out to be 202 upon 230. Now, is it in the simplest form? Still in the simplest form? Well, it's still a very big number, right? Okay, so let me find out a table in which these both numbers come, or a number from which both the numbers are divisible. The same number from which both the numbers are divisible. So let me divide this by 2 and 2, because I know this is an even number. 2 at the back, at the last digit, and 0. So pretty sure that it's an even number, so it is divisible by 2. Let's be very simple and straightforward, right? Yeah, so even divisible by 2. Let's do it. So by dividing it, I get, when I divide 202, I get 101 over, when I divide 230, what do I get? I'll divide by 2, I get 115. I think this we all know. Not a problem in this for sure. Okay. Now, is it now in the simplest form? Let me see. Okay, I know the divisibility test. I know all the divisibility tests, right? Till at least 10. I know it. So is it first, let's every number is divisible. So we don't need to check. Let's figure out 2. So for 2, is it an even number? No, it's not divisible. Let's make it for 3. Okay, let me add the numbers. 1 plus 0 plus 1. It's 2. Is 2 divisible by 3? No, it is not. So similarly, I'll keep on using different tables of divisibility tests to know is it both these numbers are coming in a same number. 4, not possible. Right. 5, is it at the end? 5. The lower one is divisible. That is right. But how about the upper number? Is it divisible? No. So this is not possible. If it's not divisible by 3 nor by 2, is it divisible by 6? No. Okay, so by doing this, I get to know that I am not able to solve it more. So this is the last which I can do. There is no table except one in which these two numbers come. So this is the lowest term. So is it the answer now? I have got the lowest term which was required. Is it the answer? No, right. Because we need to calculate what is the ratio. Is it in the form of ratio? No. So how do we write the ratio? The ratio is written, the first comes first. So 101 is separated with the other number. The second numbers follow. And what do we write in between? We write is to or the semicolon. Right. So the answer is 101 is to 115. Who all have done it? Give me a thumbs up. Who all have done this solved? Well done. A huge applause for you all. You have done it beautifully. If you have done this yourself, great. And if you're not, then just wait. It's still okay. The more questions you'll practice, the more easy it will become for you also. So let's do more. Don't worry. You'll be able to solve it if you're not able to do it till now. Okay. All right. So let's go to the other question. What does the other question say? It says that Rahul has 10 candies. Okay. And Renu has 5 kg apple. Rahul has 10 candies and Renu has 5 kgs of apples. Can we compare the number of candies and the weight of apples to find their ratio? So at one place, I have the number of candies, whereas with the other hand, I have the weight of apples. So can I compare these two things? Till now, before this, we were comparing both the units were height, right? Or the cookies were compared if we had to, right? And the third question we did, or the number of questions we did on the school, number of boys, number of girls, they had the same number. There was a number that was counted, right? But now for here, we are comparing the number of candies and the weight of apple. So is it comparable? Can we compare these two things? No, we cannot. The answer is no. Why? Why is the answer no? See, here, both of the things are different. Their units are different. Their way of comparison is different. I cannot compare the number of candies. There can be 2 candies, 3 candies, 4 candies, 100 candies. Each number of candy has a unit. Whereas in terms of weight, we use it in kilograms, grams, milligrams. They are different units and each of them has their different ways of calculation. So we cannot balance it. We don't know exactly where these two are equal so that we can find the ratio. Are you getting the point? See, I'll repeat myself again. I know the number of candies. It can be any number. That is not a problem for us. We can compare the number of candies, but with the same number of something else. It has to be the same unit. I cannot compare the number of candies with the weight because the weight is a different unit altogether. It may be grams, it may be kilograms, or it may be milligrams as well, a smallest unit as well. So for comparison in terms of ratio, it is only done when the two quantities are in same unit. Can you see the same unit? Yes, so the unit is important. So what do we come in to know by this? that the ratio itself, the name ratio, does not have any unit. It just takes the unit of what is given in the question. So when we are about to solve the question, we have to very much be very careful and keep this in mind that the question has the same units. Clear? Okay, I'll repeat once more. Listen to it very carefully. Okay, it says, see, the ratio itself has no unit at all. So we can compare anything. So ratio does not have any unit of comparison. The unit is coming from the things which we are comparing. Like if we are comparing number of candies with number of chocolates, even though the things are different, but the comparison unit, I'll have 100, I can have 10. There will be a number, right? It's a number, an integer would be there. Similarly, when I go to other way, if I compare the weight of apple and a weights of mango, suppose, okay? Here we are just comparing the weights. So both the weights are the same unit, the grams. I cannot compare grams with liters, can we? Can I compare the number of apples with the weight of apples with the volume of water in the bottle? No, because they are compared totally different. That is a different topic. That is a different concept. So we only compare the things which are on the same level, the same equal things, the same unit. Okay. So comparison is done when the things are on the same unit. Is it clear? Okay, I'll give you one more example. If I say, let's talk about a very big person, okay, who has a lot of knowledge of maths. And let me talk about a small child who is at 5th level. So if I'm comparing the knowledge, so it's a vast of difference because I'm comparing both the things at the same. How about if I compare the age of the small child and the knowledge of the bigger one? Is it any comparison between them? No, because that irony is the baby is small or is big. How old he is? He's a teenager. That is calculated on the ages, how old he is. Whereas that knowledge, the power, the education, the qualification is calculated on different terms. So there is no comparison between the qualification and the age. Now you're getting the point? So we have to only compare the same units. Okay? Okay, let's move ahead now. I hope it's pretty sure now. Now you know what we are talking about. How do we compare? Okay, now you will tell me. So give me some examples that can be compared and give me which cannot be compared. Yes? Yes, the things which can be compared are length, weight, height, right? If I compare height with height, if I compare weight with weight, these are comparable. Whereas if I compare length with weight, that is not comparable. If I compare the distance with speed, that is different. That is not comparable. Okay. Now let's solve this. The number of fishes and the number of apples that can fit exactly in the same truck. So there's the same truck. In this, the number of apples are 6,000. And here the number of fishes are 4,000. So we have to compare. So can you? 6,000 is the number of apples. 4,000 is the number of fishes. So what is the ratio of number of apples and fishes that can fit in the truck? Yeah, do it quickly. I'll show you the question. Just 2 seconds for this. Quickly do it. Yes, yes, you can do it. Yes. Okay. So how do we go about it? What do we have to compare first? We have to compare, let me show it to you again, the ratio of number of apples. So apples will come first and the fish will come later. So it is number of apples are 6,000, whereas the number of fishes are 4,000. So I'll write, I know I can cancel these zeros. It comes 6 by 4. It is divisible by 2, both the tables, right? So it comes 3 by 2. So the ratio is 3:2. Well done. You did it right. Perfect. I hope now it's pretty sure. I'm pretty sure that it's clear. So let's observe the following ratios. Can you find any similarities in these ratios? Can you see any similarities? Think over it. Look carefully. Can you see anything similar to this? Yes, take your time. Yes, yes, you can do it. Okay, I can see more answers now. Yes, there is a similarity. What is it? See, when I solve these fractions to bring it to the lowest form, because they are on a bigger height, they are different numbers, there are different places, different quantities, different things they are comparing, right? But when I bring it to this lowest form, so when I bring 18 by 30 to its lowest form, let me divide it by, what do I divide it with? Let me divide by 3. Okay, it comes out to be 6 by 10. Okay, now I see these two fractions are a little same. Okay, even I can go it more and solve it. But let me hold on here because I'm getting a similarity. I need to know, are they same? Is there something similar in this? So I'm coming back to 6 by 10. Okay, let me solve this one. 12 by 20. Okay, I know I can divide it by 2. They are even numbers. That comes out to be 6 by 10. So what did I see? By solving these two fractions, I'm coming back to the middle fraction, that is 6 by 10. So by any hook or crook, whenever I'm solving, I'm coming back to this. So what is similar? The similarity is that these fractions are almost same. They have the same value. Same value. So on solving these, we get the same result. The result is 3 by 5. How is it 3 by 5? We did 6 by 10. But this was not the smallest, the lowest form. It was not there. I still know I have two numbers in common. The table of 2 is in common. So by solving this, I get 3 by 5. So now this is the smallest term, right? So I know by solving these fractions, I get that it is giving me the same result. So on solving the fraction, which gives us the same result, we call it equivalent fractions. See, simple as that. If I get two things which are same, that means they are equal. The words equal itself becomes an equivalent. So from equivalent, equal. Can you see that? Similar? Right. So equivalent and equal, they are both same. Okay, the fractions which are same are called equivalent fractions. Easy peasy, lemon squeezy. Okay, so what are equivalent fractions or equivalent ratios? Oh, I said fractions. No, no, no. That is like in a form of fractions. But here we are talking about ratios. I'm sorry. Okay, so when two ratios have same value, these are called equivalent ratios. Yes. So we can get equivalent ratios by multiplying or dividing the numerator and the denominator by the same number. So see, it's coming back to numerator, denominator. So ratios and fractions are similar. They are very much near to each other. There is a slighter of difference. There's a thin line between both the topics. So that I'll explain you in the further classes. Don't worry, I'll tell you. That's why we say on saying fractions, because all the fractions can be written in a form of a ratio. Okay, but how? That I'll more in further classes. When you keep on joining, I'll teach you. So till now, we all know what is equivalent ratios. The ratios which have the same value are called equivalent ratios. Till now, is everything clear? Sure. Okay. So how do we calculate equivalent ratios? How I know that these two ratios are equivalent? We know 5 by 2. We know 5 by 2. So when I multiply it by 2 on numerator and denominator, I get 10 by 4. Similarly, when I multiply 2, 5 by 2, multiplied by 3 by 3, I get the same ratio. It's multiplying the same number with the numerator on the top and the same number at the bottom. So when I multiply 5 by 2 on the both numerator and denominator, I get 10 by 4. Yeah, 5 2s are 10, 2 2s are 4. Same, when I multiply these numbers again, I get a bigger fraction, a bigger ratio. See, I get a bigger ratio, but all these ratios are same. They are all same value. So they are equivalent ratio. So I'll give you just 2-3 seconds to solve this. Let's do it. Let's show me. Can you do this? Come on, let's do it. So to find more, we have done it with 2. Let's do it with 3. We can do it any number. You can do it by 5, you can do it by 10, whichever you feel it's comfortable. So we'll always start from the smaller ones because that makes our multiplication a little easier. How about solving it 105? So a little more tough. Why to do it? Let us do simple, right? And give the answer. So when I solve it by 3, what do I get? 15 by 6. Now, this is right. So this will be 15 is to 6. Is it right? Yeah. Okay. Now, if I multiply 15 by again 3 and 6 by again 3, what do I get? 45 over 18. Yes, we did it. Yes. Clear? So we are multiplying the same number to the numerator on the top and the same number at the bottom, and we are getting equivalent fractions. Okay, so now I'll give you some questions. You need to practice this. This is what you have to do now. So you have to find the equivalent ratios of 4:5 and 1:3. This is your homework. Let's meet next time and give me these answers. It's your homework. You need to practice this and you have to give me the right answers when you're back next time, right? Okay, so kindly solve this and let me revise whatever we have done. Let me compile all the things. What is ratio? What all we have done today? Can we? Okay, so let's do that. So I'll come back to the topic from where did we started. What is ratio? What all we have done in this 1 hour class. Okay. All right. The first thing first. What is ratio? What have we done? What is ratio? The chapter itself says ratios, right? So what is ratio? Ratio is comparing two things. So we compare a lot of things, right? So why ratio was introduced? We used to compare it by using subtraction. We did it first, right? But in that we did how much more. How much more a person had. The quantity was compared in terms of number in comparison, just how much more. Whereas now in ratios, we compare how many times. Times is the topic. Kitna zyada, but kitna bari zyada, kitna times zyada is the concept. There is where the ratio comes. Okay, so comparing two quantities and knowing the answer how many times. Is it easy for everything? No, the important thing is that it should have the same unit. Same unit is very important. Yes, the comparison has to be done in same quantities of same things. Now, this was the concept of ratio, and we also covered equivalent ratio. What was equivalent ratios? Equivalent ratios were the ratios which have the same value. Two ratios which are equal at the same level. Same level, equal. If you and your friend is scoring same, we say, we have got equal marks. Similarly, when two ratios are equal, we call it equivalent ratios. So in this case, when two ratios are equal at the same point, we call it equivalent ratios. And that is the concept, equal value. Two ratios at the equal value is called equivalent ratio. So we did all the things. So guys, we did it. Finally, we know what is ratio. We know how to compare units and we know what are equivalent ratios. Yuppie, we did it. Okay, so this is your homework. Meet you in the next class with more of excitement, something new in this topic. We have divided this subject, this topic, into more classes. So in the next class, we'll move further. So I'll see you all there. Please join in and understand. Come and learn with the company Swiflearn. We all are there to help you all so that you know what maths is. Don't think maths is a big thing that no one can do. Anyone can solve it. It's just you need to be a little more careful in solving the questions, and you know how to do it. You know the exact method, the exact operation, and what is the logic behind it. Why are we using it? That's it. It's so easy. Yeah, I know you can do it. Yeah, I know. I can see that excitement. Give me a thumbs up. Everybody, give me a thumbs up. Yes. Okay, so I'm very excited to teach you more ahead of this topic and meet you soon in the next class. All right, then. Kindly do the homework. Let's solve it. It's just few seconds of questions, right? We have done it. We have done it so many. We know it how to do it. So let's revise it. Okay, in the next class, meet you all with these answers and more energy, more power, and more topics to study. Okay, then, bye-bye. See you all again in the next class. Take care. Bye from Hanif ma'am. Take care, everyone. Okay, bye-bye.